Hello everyone. Thank you for joining for today's webinar. I would like to introduce you to all the panelists for today. My name is Sneha and I am community manager at Whizlabs. Today we have speaker of the day, Shantanu Singh. Shantanu, please switch on your video. Yes. Hi, Shantanu. And we have Abhishek and Mayank also with us. So let me introduce you to our speaker. So Shantanu is a technology expert and an open source consultant. He was also the VP of technology at No Cross, and he has an extensive experience in technology, business, and startups. So thank you so much, Shantanu, for joining us for today's webinar. We are really excited for this one. And then we have Abhishek and Mayank, who are from the products team at Whizlabs. They are the Cloud Products Associates. So they will also be answering a couple of queries for you today. So yeah, over to you, Shantanu. All the best. Shantanu, you are not audible. Can you try using any headphones or something? Yes, Shantanu. No, you're not audible right now. Maybe try joining again or try using some headphones or something.
Yeah, hello. Can you hear me now? Is it audible?
Yeah, we can hear you now. Perfect.
Yeah, clear?
Yes.
I think now I have to switch on the camera. I probably it was a problem with my camera itself. Anyway,
Yeah.
so I hope it is loud and clear.
Yes, perfect now.
Okay, so guys, first of all, Sneha, I have moved out of No Cross. I'm now associated with Infotel Group, where I'm heading the
Actually,
technology for
was
the whole group.
VP. That's why I said was.
Absolutely. So anyway, so to start with, uh, let me start my presentation and then we can look into it. Uh, let me give you a brief introduction about myself, guys. So I am a engineering head for a long time. I've been taking care of technology for various organizations. My experience is around 20 years where I help scale organization from very small, not just the organization, but the business itself. Because the technology, for example, is the backbone of everything and anything we do. And that's why it is, critical that, our whatever we do, it scale with, uh, you know, uh, with the business itself. So while, your organization will grow as much as the business will want it to grow, but most importantly it is absolutely your technology which need to respond to the business all the time. And that's where we start organization. Where do you stand today is more important than uh, you know uh, where you started, right? But more important than that is that where you're heading toward. How does it impact? When you talk about architecture, design, scale, and everything, it is all contextual. It is context to what you are currently doing. What kind of scale you want to handle in future. Let's say in 3 year, maximum in 1 year, 3 year, right? And remember that whatever you are doing, there's always a time when you need to decide, change your strategy, and move to something more what we called as different from what you have been doing, right? Business, for example, pivot from doing one thing to another, right? Similarly, technology also evolve. So here is it. So just starting my presentation. sharing screen. So guys, the tech world. All right, so yeah, here it is. Can you see my screen, please? Somebody confirm.
Yes, yes, Shantanu, we are able to see your
All right,
screen.
great. So as I started, so my first question for every one of you is that, where do you stand and where do you want to see, right? Obviously, everybody want to be Google someday, everybody want to be Netflix someday. But is this something which you are ready for? Netflix has like 200 million subscriber and they are in 200 countries, right? Every day a user, consume around 2.2 hour of video, right? One of their users. So the kind of scale these guys work is in interest, right? We developer and engineers, we get excited about seeing some fancy architecture which is very easy to implement using open source technology. And that's where the problem arises, because what we are seeing is that, we try to overburden ourselves from the requirement of what is out there. What basically is being created for a multi-billion-dollar organization. We want to implement that in our system itself. So that's where the challenge arises, and that's where the problem is, right? But it's not that the problem. Thinking too far is a bad thing, but thinking too near is also a bad thing. They both of them doesn't really help you, and you should avoid both of them. So that's how it is. So pattern of scaling. How do we actually scale? So you when you start your business, and I think there would be lots of technology people out here, uh, but there would be other peoples, for example, who are not who don't understand the technology well. So one thing generally everybody do is that we throw hardware, right? And I don't say that's a bad strategy, right? Short term strategy, you have a problem and you have a challenge, you want to scale it to the next level. What do? You basically make sure that your customer are served. Easier is that if you have a 4 GB RAM or 8 GB RAM server, you put it, make it 16 GB. If it's a 16 GB, you make 32 GB. All organizations which I have worked, uh, wherever we work, people try to solve this problem a lot by doing this, throwing, what called as hardware to the problem. But it has its limit, because the point is that you can only scale a hardware to a certain level. You can have X amount of memory to it, and then at that time, as you keep on increasing, the load, situation become challenging. You can't depend upon one server. One server is still one server, no matter how much memory, RAM, everything it has. So obviously people understand, okay, we are on the AWS, and probably this is not how we are going to. So even if people are on AWS, they don't really look into that thing. They practically will be doing, okay, I have a EC2 instance, let's just upgrade it, and that will solve my problem. So hardware, throwing hardware to a problem solve the problem. It actually help you, but it help for a very small time. But again, back to that problem, because there is a limitation to how much scaling you can do. That's called scaling up. So best solution is always horizontal scaling, or what we call as putting more small bit of infra around it in the place of just increasing one server around. So scaling out is the best way of solving such kind of problem, and that's how you need to be always wide. But scaling out is not easy, right? Most systems which need to be, any system that need to be scaled out, it is also distribution of work. It is also of doing same work by two different systems. So that's where we see lots of challenge. The fundamental design of solving a problem is what British had done with India also. It's divide and rule. So if there is one system, you cannot solve a problem for it. What you need to do is you need to divide your problem and then conquer it. You need to make sure that each your part of your application, all of them are like doing their particular work, right? They are not basically all of them are doing the same task. Doing same task will not help you out a lot. So the fundamental rule of scaling is separation of cluster. And how do we do it? The whole presentation is all about it. That's what I'm saying. The presentation is all about it. How do we separate the concern, right? The third part is obviously building versus borrowing. You must, when you start, you have like great engineers, you would have probably get IITs and all, and you think, okay, we can build it and all. It's a great idea to build, right? So the point is that, however, when you're a startup, the other thing which you really like is that you understand that their core competency. I want to do this. I will focus on to this. I'm not here to create a accounting software. I'm not here to solve the problem of communication or let's say customer support, right? So I'll use some software like Intercom. I would like to use Zoho, CRM, and other things which does the thing properly. Similarly, when you are an engineer, you also need to know that not every problem need to be solved by yourself. You cannot go and continue and try to solve each and every problem. What you need to do is you need to focus on the core system which need to be done really good, and pick up an open source technology which does everything else for you. That's the beauty lie, because once you you can always write great code, but the important thing about is that whatever you are going to write, it is going to fail someday. So you should say, oh, I can get great people who can write great code, and obviously, if you are writing great code, why would my system fail? But don't worry, whatever you think, whatever idea you have about it, whatever challenges you have anticipated, things going to go bad, things will go fail, things will fail. And therefore it is kind of very important that you are always ready for handling the failure. That is the most important. You do a great job, but be ready for the failure. Not only failure, post failure action is also required. Your system failed, you recovered, and once you recovered, what did you did next? Were you able to find out the problem right easily, or it took forever for you, or it take like, okay, I don't know where the problem is, but we are trying, we'll continue to do whatever we want to do, and tomorrow if the problem arise again, I have no idea what I'm. So write great code, but always take care of the failure part of it. Understand how to handle the failure, design for failure, design in a way that you are able to handle the failure, right? So that's the next point, right? When things go wrong, make sure that you have robust monitoring, log analysis. So how does it really help? It really help in making sure that whenever if a problem arises, you are able to quickly get on your foot, right? There is always a challenge. So when you are in consumer, there is a disadvantage and advantage of every business. Enterprise business is generally not 24/7. You can take a downtime and you can fix a problem. Consumer business is always 24/7, but in a way, if you have a large scale number of customers, your downtime may impact a little bit of your customer. You will always have a large number of customers with you. So remember that failure will happen, and you should always design for failure. So that's the best first part of it. So now the question arises. This is the basic thing which I have seen in most organizations. This is how they start. They have a probably firewall kind of system, or they will have some kind of load balancer, and behind them they would have their lamp application, and then there would be a database system, right? And this is how generally company organized start. Probably an Angular application or React application written in front end, which is being served if they have created the API, obviously. So that's what we are going to come next. And then obviously it's a one application which is basically serving all their customers, right? And yeah, if you have load, somebody will suggest you, oh, put another Apache, and then we will have a great load balancing capability out there. If you are on Node, then you create a new instance of Node. If you are running a ASP.NET application, then create another instance which take care of that. So this is generally things work. And as the scale, as the challenges become, if you're not right aligned to understand the problem, if you don't understand the concern, and the what we call as separation of concern. You would rather go into a design where you will probably put a caching system which will try to help you out, and you will have a database which will have master and slave. But will this help? Will this help in long term? I mean, you can obviously do it. It will be able to handle your load. But how do we make sure that we stay uh, abreast with the customer's requirement? I mean, the customer scale. If more customers are going, how I'm going to solve this problem? Will just adding more, you know more slave to your master database? I'm not sure. A lot of people, startup doesn't really like database like MS SQL Server or Oracle, but a lot of people will put everything and anything on the database, and then they hope that oh, it's Oracle, it will scale. Let's put everything into Oracle. It's my MS SQL Server. I can write all store procedure and everything, and it will still be able to handle it. But after some day, you reach a place where you obviously are confused whether how would it work, and have one big large piece of monolithic system which you are neither able to edit it, neither you are able to add new features, neither you are able to solve it. So that's the first part of it. And I'll take a break now, and while you ponder about this thought, we'll join again. Meanwhile, Whizlabs team. Yeah, Sneha, do you have any? You want me to take some questions?
Yeah, uh, we don't have any questions as of now. Attendees, if they have any questions, you can put in the chat box or in the Q&A section. I think you can
Great, great,
go ahead as of now. Yeah.
great. So should I continue with the next part?
Yes,
Uh,
yes.
okay, great. Okay, so guys, the first thing, when you are designing any application, if you are startup founders, if you are engineers, and if you are a small business or big business, doesn't matter. But the fact remains that today the world has moved something different. You know, you have moved to being responsive to the customer, and being responsive to the customer doesn't even mean that you are just focusing on delivering the value through one platform. You are omnipresent. You have to be omnipresent because your customer is omnipresent, right? He is in the mobile device, he's using you know laptop, he's using desktop app, everything, whatever it comes, he's using a tablet, for example. So the fundamental thing is that you need to be present to the customer in all the device where he is, right? He would like you to be there. So whatever you design has to be able to respond to multiple devices. And how do you do that? When the fundamental rule again, which I have talked about before also, separation of concern, right? So when you are able to understand that there is a backend system, right, and there is a front end system, then you are able to design system for front end as well as the backend. So pick up your front end tool, right? Whatever it is, whether whether you love React, whether you are into completely into Angular, but on the back end have an API driven REST API, JSON based REST API architecture. And why it is important? Because by being using this kind of architecture, you are able to, this is a very fundamental thing. I'm not saying that you are not actually already doing it, right? But by doing it, you are able to serve lots of customers. You are able to serve customer on different devices. Not only that, you become open to integration, right? So tomorrow if some of your vendor comes and he is really into looking for, okay guys, can you provide this API for your this system, you can probably provide him, right? Obviously after implementing the right authentication and authorization mechanisms. So that's very much possible. It is only possible when you are API first design company. It's your responsibility. You don't write any code which is not API native. You don't mix, you know, what we call as a presentation layer into the API. So that's something which you should not be doing at all. And yeah, that's the fundamental thing, and what value you get out of it, your application is developed faster because people can work on a certain part of API. You can plan better because you already know what you are going to develop, right? Use Swagger, for example. I'm not sure when I meet, visit certain company or friends and all. A lot of people are developing API, but they never use Swagger. Why do Swagger is an open API, specification, and there are tools which enable your API to use Swagger, whether you are using Node.js, Angular, Go, or anything else, right? It's fairly simple. And what value it brings to you is massive. It practically make your API self documentable. It also makes somebody who is not part of your team to be able to understand that API much better. So use Swagger, use API first architecture. Then the other thing, yeah, a lot of people don't know about it. Lot of people don't talk about it, but this is going to be very, very important. When you have API, the other challenge related to API is API management, right? So you have API, you have certain API that need to be changed, modified, and all. You need to be able to serve certain customer, certain set of API, right? Because as I talk to you, when you open your horizon, you get a lot of possibility. You have now created API, right? And suddenly one of your good friend comes that, if you integrate with my this platform, you the amazing thing which is going to happen is that you will get another 100 customer because I already have such customer and they have similar kind of requirement. Using your application will solve the requirement, and since you have already created the API, why don't we just use it? Great idea. But API changes with time, endpoint changes with time. Well, endpoint changing of end time is like, your API being served by X URL, tomorrow it need to be served by Y URL. So API gateway is an application which would allow you to practically do that without any change. So API gateway sits between your APIs, right? And it deliver all your APIs to your customer. It provide a manageability. It provide you API monitoring. It provide you throttling. It will provide you basically, expiring and changing your API. So suppose, one set of API which was being served through API1.myserver.com. Tomorrow, your internal server changes. You have set up a new and upgraded API. They can rather be served through API2.myserver.com. While for the customer, the URL will always, or customer or somebody who's consuming the API, the URL will always be API myserver.com or API.myserver. So that's a very important way. This is the part of growing up. This is complex. It comes with lots of learning, but once you implement it, your life is much easy. So go for it. When you design your application, make sure you are implementing an API gateway. Basic thing. Load increases. What do? You try to vertically scale your server, but there's a limit to scaling it vertically. So what do you do? And you thought about horizontal scaling. But how do you implement horizontal scaling? Horizontal scaling is implemented using load balancer. AWS people would know it by ALB, NLB, and other. Open source people know it by proxy. Even internally to AWS, they also know it by proxy. So lots of people use proxy or Nginx and other for as a load balancer. Why load balancer? Because load balancer is able to distribute the load to your API gateway or your APIs very easily. It is able to take care of your security concerns. So if you should know, if you are a performance guy, you'd know that today everybody asks you to be on SSL, right? But being on SSL also means that it's a time consuming stuff. However, what you can do about it is that your load balancer can accept the SSL traffic, while inside your system it is all non-HTTP server traffic. How does it help you? It helps you with the performance. So load balancer is able to distribute the load, which in fact help you to scale horizontally. Your load balancer not always sit in the front of your server. It does that sit in many contexts, right? It can be actually balancing the load between multiple uh, zones, uh, you know regional zones and all. Not only that, but it could be actually distributing the load between your let's say various API gateway to your database server, that kind of thing. So that's pretty much there. So load balancer is a fundamental thing which you need to have in your design. And the disconnected essential. Now, this is something which I've interviewed so many people, and a lot of time I'm surprised that people are not using messaging queue. Messaging queue is the fundamental of disconnected architectures. It is also the fundamental of microservice architecture. Why messaging queue is important? Because of the very, very important reason that it allows you to be asynchronous to your customers. Why do you need asynchronous communication? Because not every communication will be done within second. Not every response can be generated within second. Suppose you are uploading a PDF and your system need to, and I when I'm asking hiring architects and all, I just ask them question: how do you handle if your customers require you to upload a PDF file? How do you make sure that you know the customer is responded within time, if there is a processing involved into it? So for example, let's say your customer is uploading lots of you know documents, right? And there are certain services which basically use some AI to identify and categorize the data inside that document, right? So that you can in future search it. If you have a synchronous system, right, you will practically receive that data or query, right, and then you'll call the third party API, which will take its sweet time, and then you will try to respond to your customer. That would be very late. Your customer would be saying this circle moving forever, and he would be kind of tired of it. What do you generally do is you disconnect it. You accept file and you do the task, whatever task that need to be done on that file in asynchronous manner. And this asynchronicity is provided by messaging queue. So messaging queue allow you to basically respond asynchronously, and it is the essential part of how your modules, services, or apps communicate with each other. For synchronous communication, you can use HTTP, but for asynchronous communication, you always use messaging. If you guys have complex problem and you work on a large scale, some of the people organization use Kafka, but RightQ does a great job wherever else it is required. So learn about messaging too, because this is the fundamental of all disconnected architecture, and this is the essential part of microservice architecture. The microservices. Why microservices? Why not monolithic? How would it help me? So, and it is too complicated for my developer, I should not be writing it. That happen a lot of time. People think that way, and obviously people kind of like to do things which are easy. But microservice may be complex, may look complex for a lot of people, but it's not that difficult. And now most platforms support them how to write a great microservices. But the basic concept of microservice remains same. It is stateless, which means that you don't practically have a session which is running around. You have an authentication and authorization microservice, which practically makes sure that what can be accessed and what cannot be accessed. Microservices are self-sustained. They can be scaled individually, which means that suppose you are seeing that you are getting lots of searches, right, but a little bit of actual closure. What you can do is you can practically use microservices. What you can do is you can scale that particular microservices. Since microservices are deployed individually, you can scale whatever specific part of microservice individually, and that's how the correct design of application should be. Because what we are seeing here is you know uh, microservices allowing you to have that disconnected architecture, and it is also helping you basically distribute your load across the systems. So if your application does 5 things, it can very well be doing it uh, with 5 different microservices. Microservices can communicate with each other synchronously and asynchronously. We discuss about how they communicate asynchronously. It is obviously using messaging queue. And the biggest benefit which I found with microservices was that I was able to use the technology which make more sense to me. What does it mean by the technology that make more sense to me? I find out that it is much easier to design some system application, right, in Go as compared to Python, right, where I need more uh, parallelism, right? So I implement that in Go, and that was a Go microservices, and it was sitting just with the Python services. Similarly, I realized that certain services, certain open source module which I am using is completely written in PHP, and the best way to engage and communicate with it or extend it is using PHP only. So I created a PHP based wrapper to communicate with it. I found out that there are certain things which can be done better using Microsoft technologies. So I created a microservice in C Sharp. All of these services can work parallelly together, and that's the beauty of microservices. It allows you to serve your customer through the right use of technology, tool, and language. That's where the microservices come. Not only that, when you create microservices, your specific microservices can help you uh, to basically create a new business altogether. You find out that something was really great about your application. There are certain services. Let's say you have created a microservice which create all the different kind of what we call as a thumbnail for your out of it, it take a picture inside and then it create thumbnails and different size image and all, right? And this is developed by one of your engineering team. You can very well practically use that technology to leverage in any products inside, or you can also leverage it outside, which means you can actually give as a service to your customers. Think about it. Microservice has great advantage. It help you to easily. And one of the thing which I have also seen, I was talking to somebody who has a challenge related to their what we call as uh, um, your code debt, which practically mean that they have lots of old code, right? And which need to be replaced. So I said, what should be? They were asking, what should we be doing, to make sure that we are able to handle these challenges. I suggested then, whenever you're writing, write more microservices, because microservice is a unit. Tomorrow, if you find out that the code is not that great and it will require certain changes, or the technology or systems or compliance is required to be changed, then you can practically change it, completely change it, and attach a new system to it. So that's why microservice is important. This is the fundamental of disconnecting the concern, disconnected concern. Now, this is a very basic thing, but there are certain application which lives by them, right? As we come to end of this session, so I just want to talk about this very important thing. So, when you are serving certain data, you use different kind of database. You probably could be using a data store like MySQL. I call them databases, RDBMS databases, like MySQL, Oracle, SQL Server, or you could be using a NoSQL database like MongoDB. It is important to understand that if a response need to be done faster, it has to be through memory. We have made great leap in how fast our IOs has become, right? From 135 to 500 IOPS when we talk about SCSI and ISAS, to SSD, which is from somewhere around 4,000, 45,000 kind of IOPS, and to Optane, which is like 1.5 million IOPS. So IOPS, which is basically means that it is the getting data from the storage is much faster, right? But then even storage is storage. If your system is going to look up data every time from the storage, it is only going to cause delay in serving the customer, because there is not one customer who is looking for data. There are multiple customers. So if there are so many customers who are looking for data, better to use a system like Redis, which basically give your data immediately to you. Redis is a in-memory, we call as a caching services, right? So its name actually come from remote dictionary server. So basically, it's a key value pair, key value kind of system, but it has now extended to do lots of different things. But it is one product or one open source technology which is must required when you are creating for scale. So that's what you need to focus on. You need to make sure that all your queries, whenever you are getting data from a data store, you're also checking your cache to make sure that your whether that information stored cache. Start using cache if you are not using one. The simplest use and you can start is moving your, if you are a session based application, I will not suggest it anymore. Move everything to session less. But if you have a session less application, probably you are using Redis, or you should use Redis because it's a centralized storage for your sessions. Move away from session and think from the broader context, where you should also think that your data, uh, your application need not to go to database every time when it needs certain data. So that's rule number one. The rule number one is so rule number one is basically to get into use something elastic search, right? So how does Elasticsearch works here? So Elasticsearch works by providing you, instant response to whatever data which you are looking. So if you think from the context that your data is sitting out there in your database, or cache is getting your data faster, but when there is a large amount of search requirement, it's always good to use Elasticsearch. Elasticsearch respond faster. It get your information whatever you want to look. Not only that, it also is able to basically respond better than anything you would ever seen. So anything, if you want to serve your customer where there is a search scenario, use Elasticsearch. There are other competing tool that compete with Elastic, but this one is the best, and Elasticsearch really work well. So if you are creating a web applications where there is a requirement of text response, and it would always be, there would be a response of, let's say you have lots of detail about cars, let's say you have a lot of detail about your products and all of this could be put into Elasticsearch, and then this information can be provided to you at the very instance. It's a sub millisecond response. That's what Elasticsearch give you, and it's amazingly fast. It's really very fast. It is not robust, but it's really fast, and it is something which you need to have if you are going to respond to your customer fast. So that's the basic pattern of what we want to do. Finally, if you have to put all this together, how does your application should look like? So your application should be sitting behind a load balancer, right? Oh, sorry. Yeah, in the primary contact point for your customer would be a load balancer. And load balancer, lots of organizations use NLB, ALB, or HA proxy. So that's the primary place where your customer should be interacting. Lots of people implement firewall, but I suggest against going with firewall, because uh, if you want to stop some kind of communication, that can also be done by simple rules. Behind that load balancer, there should be API gateway, because API gateway is able to basically manage your API for you, and it is able to scale pretty well. It is able to provide you enough security. It is able to provide you authentication and authorization. Lots of API gateway come inbuilt with the authentication and authorization server, which you can utilize and integrate with your system. So all of this, there are technology in AWS, there are technology in Azure, and there are technology in open source which compete with each other, and they provide the similar thing. So if I'm talking about API gateway, as AWS provided API gateway. Similarly, if you want to use open source one, there are WSO2, there is COM, there are various other API gateways you can use. Then it is your services. Services has to be microservices. They should engage and communicate over messaging queue. And not only that, your service, your microservices should either preferably be containerized, or if they are not containerized, they should be put into a system where they can auto scale. Lots of service provider like E2E and DigitalOcean and obviously AWS and all, they provide auto scale capability. So you choose how you want to auto scale. You can either be scaling generally it is far better to scale a container using Kubernetes or Fargate or something like that. But if you want to scale a virtual machine, you can also do that. After that, is important that you have implemented Redis. Redis is one name which obviously come. There are other also. You have CouchDB, Memcache, and all. But Redis has become one of the popular one out there. And with that, the last is your database. So database also, if you want to scale, um, there are multiple way, and it has been traditional. The database is a traditional thing, so you can use master slave and all. But there are new technology like max scale, which allow you to have master applications. But other than that, you can also use technology provided, some technology like RDS, which is provided by DigitalOcean, E2E also, and I think is also provided by AWS. Is somebody who are known for that. So RDS is something which can really scale well, and you can easily manage, maintain, and scale it whenever you want. Obviously, if you want to serve some data instantaneously, Elastic is a great solution. Don't rely upon it. You should have a great cluster, great time, create a cluster, because indexes get bad. It is all indexes, and then think it as a volatile disk-based cache, which is basically to respond customer quickly. So this in turn talk about the whole architecture of creating a very scalable system. And I now look forward for some questions. And yeah, over to Whizlab team.
Yes. Shantanu, we have one question in the Q&A section from Tarun. He's asking, sir, it means microservice design should help to solve monolithic design.
Okay. So monolithic means, one, mono means one, right? So which means that you have one big system sitting out there and is doing everything, right? When we talk about microservices, we are not talking about one system, right? We are dividing that one system into small bit, right? We are saying, okay, you were doing five things. Now you got to be five things would be done by five different systems, right? So monolithic is a problem which is solved by microservices architecture only. So you are correct on that. There's no doubt about it, and that's why people are moving to microservices because it's much easier to maintain, right? People just write the code and then they forget everything about it. But ultimately, somebody need to fix it and maintain it. So maintenance of the things and you know, debt reduction is something which you can only do when you are and you can effectively do when you are a microservices company. If you are a monolithic company, you are only increasing your debt or technical debt, as we say it.
Okay. There is one more question from Ankush. What type of application we use for Elasticsearch?
So, you know, uh, Elasticsearch is essential wherever there is a search is required, right? And if you are developing a web application, if you are developing an e-commerce application, you cannot do away without it. The response time which your customer require, right? It is very critical and it is handled by that. One of the large, so that's a fundamental thing. Any e-commerce activity has to be supported by Elasticsearch. That's one. Now, other thing is that Elastic is also used for log, what we call as taking care of cross-cutting concerns. So, what does cross-cutting concerns means here? Is that you have certain things, certain problems which need to be solved right there and then for all the complete systems. So, for example, let's say you have a situation where your systems has gone down or your system could have practically faced certain problems. So you need to find out what were the issues out there, what were the challenges out there, right? So how do you fix that? So for that, you need to have all your logs. Whatever systems is creating. You probably have certain nodes application. You have C# application running to your system, or even if you are a one company, you are using PHP or LAMP, whatever. These logs are being generated by various systems into various places, right? Your database is also creating log. So by using Elasticsearch, what you can do is you can and Elasticsearch will come with a handy tool called ELK, Elasticsearch, Kibana, and Logstash. So using this group of tool, you can practically move your all logging wherever log is happening and move that log to the centralized Elastic server. And how does it help? It practically help you search for the problem, fix the problem, and in real time identify if there is a problem with your system. So that's the second use of your Elastic. So the first rule is obviously about everywhere there is e-commerce implementation, use Elasticsearch. Second, if you have logging problem, if you have a if you have if you have a system where the logs are created, move those logs to ELK. And primary, a lot of time people also use it for reporting purpose, where they connect your Kibana, for example, is used for showing the real time uh, what we call as report. Not I would not call report, but yeah, information about the server. And if you move that or use that, consume that data into Grafana, then you are able to see nice graph about your whatever data you have.
Okay. There are a couple more questions in the Q&A section. Can you check those out too?
All right, great.
BSK Rao, can you explain what is the best solution approach for communication between microservices if it has to be synchronous way?
So microservice, if it is a synchronous communication, it has to be. There's no problem with that. REST API, all microservices should be able to communicate over REST. And if it is uh, so practically if so our API has to communicate over REST, and on REST your HTTP works very well. Don't use, if you specifically need to use HTTPS SSL, your choice, but it has to be, if it is a synchronous communication, use HTTP. That is good enough. HTTP have enough what we call as verb to handle all your requirement related to synchronous communication. So, so next question is by Karthik. In which scenario we should go ahead with monolithic architecture? You should go ahead when you are starting. I will suggest you, okay, but be always open to the change. Understand that you will have to make changes in the future as you grow. But startup get confused about creating great architecture and great product, and they get in trouble with that. See, you need to understand your business. If we need to talk about from the context of a business, you need to understand how your business will grow. Generally, everywhere and anywhere we have gone, micro if it's not microservice, it is API based service. At least things work well for a longer time, but ultimately you start having this technical debt, and that technical debt will require you to have move to the microservice architecture. So this is technically I will not recommend you go to monolithic architecture, but I'll also say it is pragmatic to use monolithic, because you know I have seen organization 5 year 8 year using their product where they have a specific number of customer, and they have a good enough team to handle it. They are able to API survive with API, but not with microservices. So you can do that if you have if your team where all the team members are working on technology. You understand that you will be always using C sharp, or you will always be using PHP. Then go ahead, use it, because then you probably will not get the advantage related to writing into multiple languages. So yeah, so that's where you can kind of use it. I'll suggest also understand how your business is growing. If it is going to grow very fast, then probably monolithic is not right for you. But any starter who have an idea, who want to get started with, even if you start with monolithic, right? Uh, have API in your thought. Think about API all the time. Don't think about microservice in the first place, but think about API in first time. So microservices, I would say that you are in stage 2, 3, then you start. Yeah. So I hope I answered your question, Karthik.
Okay, I think this answers the questions very well. Okay, now I would request Abhishek to take over and give us a quick tour of Whizlabs to the attendees. And then we will have a Q&A section and a quiz round also, where we will be rewarding those who will be answering the questions put up by Shantanu. So yes, please stay for that part. Over to you, Abhishek.
Perfect. Thank you so much, everyone, for joining. And my name is Abhishek, and I work at Whizlabs. Today, I'll just walk you through what Whizlabs has got for you when we call it as a hands-on labs. Okay, perfect. So just a quick yes or no in the chat window. How many of you have already used the labs? Can you put yes if you have used the lab previously? Just quick. There's an option in, yeah. If you have not used the labs yet, you can just put no. That's completely fine. Okay. So I see many people have used and few of them have not used. So that's completely okay. For those who have not used, I'll just take you through a quick tour of Whizlabs lab. Okay. So in this 5 minute demo, I'll be taking over for you to understand the Whizlabs platform. We have got a new user interface. I'll be exploring you through the cloud certifications and their particular practice test and online courses that we have. Along with that, I'll walk you through the lab features. And if you have any questions or queries, you can ask me. Okay, so yeah, building hands-on in live environment. What does it mean? So you just saw how Shantanu explained about load balancer, elastic cache, elastic search. All of these things are there, but when you want to do it in a real way, that's where Whizlabs comes to you rescue. And here you can see you have meaningful and relevant skills that you will learn in the real world environment. And what matters the most in the real world environment is how you do. Okay, so Whizlabs provide you the cloud resources so that you can explore the skills. And using Whizlabs Lab, there are unique number of tasks that cover different cloud services in together. I'll just show you a quick lab at the end of this demo. And here each task is considered as a single lab. Let's say if you want to solve a very small problem, or maybe how to enable logs in the CloudWatch, or how to enable logs in the API gateway. Okay, so I'll just show you this demo at the end of this slide. And you are required to perform the specific task and steps to do that. So we have got lab features and the lab tasks. Okay, so in lab features, we will give you a brief description of the lab, also the introduction to the AWS services that we used. There will be an architecture diagram of the lab explaining what you will do in the lab. Okay, and when coming to task, there are individual steps in detail. It has all the required screenshots of the AWS console. Along with that, it has the required commands, and also the code is provided as part of it. Okay, now once you are done with your lab, we give you additional feature called as validate. Okay, so validation means that there will be an automated code that will run in the background to give you a detailed report of how you have done the lab. If you have done anything which is not good, or your outcome is not as expected, the report provides all the necessary information to fix this issue in your next attempt. Also, you can submit your feedback to let us know what you think about our products. Okay, so now when I talk about doing a live environment, or doing some uh, gameplay, or just testing out some things, the very first thing that comes to my mind is, oh, I need to pay for the credit card, because when you create an AWS account, it asks for the credit card. Okay, but here at Whizlabs, learning cloud computing with live hands-on is completely risk-free. You don't need to provide your personal data. You don't need to provide your credit card information. What you need is just be as a Whizlabs user, okay, where you get the access to hands-on lab. And also, we are now building the lab challenges, okay. So it helps you with no cost accounts, no setup time, okay, and you can use your practical experience to build the things in the live environment. Okay, and you don't have to spend any time on setting up the environment, creating account, or doing any manual work out there. Okay, so this is just how one of the lab look like. This explains you each and everything in detail. Okay, so let me just switch back to the console, where we have the Whizlabs panel present for you. Okay, so I hope my screen is completely visible to you all. Perfect. Okay, so here I am on the Whizlabs page, and I haven't signed up. I haven't logged in yet. Okay, so here you can see there's a sign up and login button coming up for me. Okay, so I'll just click on the sign in, and I will use one of my email IDs where I have enrolled into the courses. So to be a Whizlabs user, you just need to enroll yourself into a course or two. Okay, and then you can go to my courses, and inside this I have one course which is in progress, showing as AWS Certified Developer Associate. Okay, so when I open this course, there are three things present. First is practice test. Let's say if you are preparing for this certification exam, we have got quite a few sections of practice test where you have lots of questions, 30 questions, 65, 65. Then there are section based question. We have 10 question, 5 questions, 7 questions based on the service, based on the topic. Okay, then we have the online course where 121 uh, content is available in form of video. Okay, and all the timings are given like this. Chapter 5 called serverless is of 1 hour 39 minute, which has 6 lectures. Okay, so this helps you with that. Now I'll be talking more about how you can use the labs, and what takes you to do a lab. Okay, so maybe I can just take this example called enabling. So I can just walk you through enabling the CloudWatch. So do we have CloudWatch labs? Correct. We have a CloudWatch lab where it says CloudWatch for resource monitoring, create CloudWatch alarms, and create the dashboard. Okay. So to access the lab, just click on the start button. Once you click on the start button, it will take you through from whizlabs.com to play.whizlabs.com. Okay, a subdomain of whizlabs.com, and here you get the access to the lab. So the lab details says this lab will walk you through the various CloudWatch features available for resource monitoring. Okay, so we all know a CloudWatch is a resource monitoring service where you get alarms, billing, event, all those things are present. So this lab is of 45-minute duration, and the region that will be used is US East Northern Virginia. Okay, the default region, and this is the architecture diagram. So here you will be using an AWS instance that will be used for the stress test. Okay, so we do a stress test to go up the alarm high so that you get the notification instantly. Okay, there will be a SNS topic, and there will be a CloudWatch dashboard just showing you all the things that are present. Okay, so as part of the lab task, you will be doing all these certain things. You will start with creating and launching an EC2 instance. You will SSH into the EC2 and install the necessary software, including stress. You will create a SNS topic. You will subscribe your email to that SNS topic. Then you will check the EC2 CPU utilization metrics. In the CloudWatch metric, you will create an alarm. After creating the alarm, you will test how it works. Okay, so I'll just take you through the steps. The first step says you launch the lab. So to launch a lab, just click on the Start Lab button. Okay. So once I click the Start Lab button, it will take 5 to 10 seconds and it will start. So lab has been started successfully, and you can just click on the Open Console button. Once you click on the Open Console button, you get the access to AWS account provided by Whizlabs. So you don't have to worry about what I said, a cost, time, cost, or setting up your account. So to log in, just copy this IAM username, which is present here, and the password, which is given here. Okay, and click on the sign in button. Once you click on the sign in button, here you go. The Whizlabs AWS account is available for you, a neat and clean place where you can do your stuff. So it starts with launching an EC2 environment, EC2 instance in the Whizlabs account, and make sure you are in Northern Virginia region. So yes, I'm in Northern Virginia region. The next task says navigate to EC2 by clicking on the services menu in the top, and then click on EC2 in the compute section. Okay, so click on the services on the top, and inside the compute section, I have got EC2. Once you click on the EC2, the next task is to navigate to instances from the left side and click on the launch instance button. So on my left hand side, I have got instances, and on the instances page, I have the launch instance button. So once I click on the launch instance button, I have to select the Amazon Linux 2 AMI. Okay, so maybe you can search for the Amazon Linux 2 AMI, but since this is built by Amazon, it is exclusively available for you on the top. You can just click on the Okay, so click on the select button that is present here for you. So let's go with select. The next task is select the T2.micro instance type of EC2, which is eligible for the free tier. So just do that. The next task is leave all the values as default and click on the add storage. So just skip this configuration detail page and add the storage, skip this part. Now add the tag which will be required. So I'll just use a name as a key and value as a tag. Okay, so add tag will be name and value will be my EC2 server. I'll click on the security group. For the security group, just select SSH, which is already being present. So you can skip this and click on the review and launch. On review and launch, just click on the launch button. And here you need to create a key pair. Okay, so to create a key pair, you can just select creating a new key pair and give it a name. The key pair type will be RSA, the default type. Okay, so name would be like CloudWatch demo. Okay, for the key. And now I can click on the download key pair. Once you download this key pair, it will be required for you to SSH. So I'll save this on my desktop and click on the save button. So once that is done, you can review all the settings and click on the launch instance button. Okay. So now I'm clicking on the launch instance, and this will take some time for launching the instance. And now here you go. Your instance is now launching. We can just view this instance. It is in pending state. Maybe it will take a minute or so for be into the running state or available state. Okay. The next task that we have to do is SSH into this EC2. Okay. So what I'm gonna do is I will uh, like skip this part. I hope you have got a basic idea of how the lab works. Okay. And I will not do the complete lab, that is not as part of this webinar. I'll just click on the validate button to see whether the EC2 that I have created is coming up into the validation or not. So definitely I'm going to fail the validation because I have not completed all the required steps as part of this lab. Okay. The validation says fail, but here you see you have created one EC2 instance and all the steps I have done it correctly. So you will get success here only when you complete all the steps as part of the lab. So whatever was instructed for you in the lab, if you do it correctly, you will get one EC2 instance that is created and also the success. I haven't created SNS, I haven't created the CloudWatch alarm, CloudWatch dashboard. So all this have failed. But here in the lab user task complete details, you can see that all the details that are present. Okay. So for EC2, I have created the EC2 with instance ID this. I have selected the Amazon Linux 2 AMI. This was my AMI version and ID with the T2.micro architecture. Okay, I have created a security group, and the rules that are open for this security group is 422. Okay, I have created a CloudWatch a key pair called CloudWatch demo. The instance is having this as a public IP. Okay, and I can now do SSH into my EC2 since I have created a key pair. So I hope you have got a good idea about the validation now. Now I'll just walk you through the some of the stats that we have. So currently we have more than 164 labs on AWS, 05 labs on Azure. These labs are getting built at a very fast pace. And then we have the GCP, Google Cloud Platform labs. Okay, so the labs are also available as per the courseware wise. So if you are enrolling yourself for AWS certified cloud practitioner, uh, we have around 21 labs that will take around 540 minutes if you do all the labs. Similarly, for all the AWS certification, we have the labs present. Okay, and yeah, let's walk you through the AWS certifications that are present currently. So to access the certification, you can go to aws.amazon.com/certification. And yeah, these are the AWS certifications that are present of four categories: foundational, associate, professional, and specialty. Okay, you can also check out the Azure certification. Just search for the Azure certifications, and they will give you a quick idea about the certifications that are present. Okay, so to access the lab, you need the access to Whizlabs platform. And if you are not a Whizlabs user, what you can do is participate in the quiz. So we have got a quiz in some time for you. The questions are being getting ready. Okay. And once you win the quiz, you will get one practice test or online course of your choice, which means that you will also get the access to hands-on lab. So if you purchase any online course or if you purchase an individual practice test, you get the access to hands-on lab for free of the cost. Okay, then you can use all the labs that is required for your certification exam journey. Okay. So do you have any questions related to Whizlabs platform? If you have, you can post in the Q&A section. Okay. Yeah. And okay, so Sneha, is the quiz ready? Quiz questions are ready?
Yes, I would request Shantanu to take over and share his screen for the quiz. So I would like to announce the special codes first for this webinar. So you can get, I mean, if you are not able to win the quiz, we have some special codes for you also, which by which you can purchase the Whizlabs online courses or practice tests, and you will be able to get access to the hands-on labs, as Abhishek mentioned in his live demo. So for today, we have these special codes, which I'm going to share in the chat box for you all. Yeah. So this is a code which you can use for the online courses and practice tests. You will get 60% off. And if you are interested in purchasing the subscription for Whizlabs, then you can get a flat 30% off by using this code, which I have shared in the chat box. So if you want to purchase, or you can share these codes with your friends and colleagues, and share these so that they can also benefit from these codes. Now I would request Shantanu to please take the quiz.
So hi guys, I have some few questions, and I'll just ask you, and I hope you would be able to answer it. Uh, Sneha, can you put the first question?
Yeah, sure.
I'll give you 30 seconds to answer it. This is a fairly simple question, nothing complicated. So just give me a second, then put it up. Okay, so I'll start the timer. Just give me a second. Okay, so I start. Snap, put the question.
Yeah.
Let's see who answers it.
Just a minute.
Okay, you need to just. Okay, great. The first question. Elastic's most popular text search engine. Name another one. Time start now. 30-second answer.
Yeah, I would request the attendees to answer in the Q&A section, not in the chat box.
Have you got any answer? Yeah, we have already got one answer. Another answer.
This time we're not keeping the MCQ ones, so you have many options to answer your questions. Yes.
All right. So let me, time's up. So let me review the answer. Where are my answers? Let me just take care of. So we got a good answer, Shrunk. So that's good. Luke got it. My next question. So these are a simple question we need. So you can also talk about leucine and other. So there are other things. So we can use one of them. Yeah. Okay. Great. Next question, please. So I only talk about one, and that was Redis. What else can you talk about it? Very simple. Yeah, I got the answer already. Yep, Memcached by Luke. Luke is answering all the questions. Very well. Thank you, Luke. Again, that's the answer. Memcache and CouchDB. I have spoken about both of them, and Couch being very popular. Memcache has been around for a very long time. Last question, please. AWS, very simple question on AWS. What are the load balancer technology available in AWS? Do we have any answer? Yeah, we already got one answer by Yes, weakest rouse is absolutely correct. It's ALB and ALB. Thank you very much. So these were the questions. I think you guys have got what I was talking about, and I hope you have great time scaling. Technology is all out to help you out. The only thing is that you need to utilize it for the best possible way. Find out the right time when you can utilize the technology. Always try to think from the basic concept that you know disconnecting the concern or separating the concern actually help you scale well. So that's something which you always should have in your mind.
Yes, thank you so much, Shantanu. If anyone wants to stay for the selfie, then please raise your hand and we will turn you into panelists and we can click a picture with all of you. Someone is asking when is the code getting expired. So this code will get expired on 25th of August. So you have 4 or 5 days to use it. Make sure you use it before the timeline. All right. Those who are interested in sharing the frame with Shantanu and the team, please raise your hand so we will turn you into panelists. Hello, Vivekanand.
So thank you once again. And in case if you need anything from me, I'm on LinkedIn, LinkedIn/in/Shantanu Chauhan, and my email ID is shantanu@mobileyuk.com. You can contact me on that. And yeah, I think Sneha, can you just share that with the members so that they have that idea?
Sure. I'll put.
Yeah. Anything and everything you want to talk about, scale, architecture, design, and engineering, I would love to take your questions and would love to answer your questions on that. It was
I'm sharing
really.
Shantanu's profile in the chat box, LinkedIn profile, so you can connect with him over there. There you go. Yes. Karthik and Xavier, could you please switch on your videos? Okay. Okay, thank you so much for coming, everyone.
Thank you, guys. Thank you very much. You have been amazing, people, and I really look forward for more such communications. It was really I really love talking to you guys, and yeah, thank you for all your questions.
Thank you so much. Bye.